Welcome everyone. In this walkthrough we're going to go over a Year 1 A-level chemistry question on equilibrium. We'll look at how to deduce equilibrium amounts. We will then go on to solve a Kc expression algebraically to find an unknown concentration. To have a go at the question yourself, you'll need a calculator. There are similar questions on the flipchem.com website. Links and login details are in the description. Black text is the question, red text is additional info, blue text is the answer. Pause the video at any time and attempt the question yourself. Let's get started. Here's the first part of the question. When substances P and Q react together to form substance R, an equilibrium is established according to the equation P plus Q is in equilibrium with 2R. The equilibrium constants expression is Kc is equal to the concentration of R squared divided by the concentration of P multiplied by the concentration of Q. 1.0 mole of P and 1.0 mole of Q were mixed in a container with a volume of 1.0 decimeters cubed. At equilibrium, X mole of P had reacted. The amount in moles of each of P and Q at equilibrium is 1 minus X. Deduce in terms of X the amount in moles of R in the equilibrium mixture. To address this question, we need to think about reacting ratios, also known as stoichiometry. 1 mole of P reacts with 1 mole of Q to produce 2 moles of R. We are given the initial amounts of P and Q, 1 mole of each. At equilibrium, X mole of P has reacted with X mole of Q to produce 2X mole of R. Here's the next part of the question. At 298 Kelvin, the value of the equilibrium constant, Kc, is equal to 3.6. Calculate a value for the equilibrium concentration in moles per decimeter cubed of R. We know the equilibrium amounts of P, Q and R from the previous part of the question. Amount is equivalent to concentration in this case because the total volume is 1 decimeter cubed. We substitute these values of concentration into the Kc expression along with the value of Kc given in the question. If we tidy this expression up a little bit, this might give you a clue about the next step. We can take the square root of both sides of the expression. Next, we have to rearrange and solve for x. All the steps for the rearrangements are given here. X works out to be 0.49 mole per decimeter cubed. You have to remember that the concentration of R at equilibrium is 2x. The answer is given to two significant figures, the same as the data in the question. The concentration of R is 0.97 mole per decimeter cubed. Thanks for watching. Please like, subscribe and hit the bell for notifications. Post in the comments if you have any questions or suggestions. Take care.